Hello everyone, hope you all are doing well. We are continuing our three-part series related to Python library development. The first part has already been done and this is the second part of our series. In the three-part series, we have already completed the part 1. In the part 1, you have learned the usage and the applications of Python library and how important it is for you to know how to develop a Python library, or you can take your application and convert that to a Python library. And now we are here at the part 2 of our series. And in this series, we are going to actually develop the Python library based on the application which we have created in the very first part of this video. The Python application which we have developed earlier has the implementation of these 4 different functions built into a single function, which can be called by selecting the choice and passing a range of values as parameters. This is the code which we have developed earlier, and this code has already been tested for its correctness, and our objective in this video is to make sure that we can install the package named Ramp Utils. The Python application which we have already built earlier will be used to convert into the Python module so that we could generate the wheel files and learn how to install them and finally consume them in a new Python application as seen in front of us. And by end of this tutorial, you will learn that how we have created this Ramp Utils package, installed it in our this currently running Python environment, and able to call the methods which we have developed here through this library. If you are looking for a reason that why do you need to learn creating Python packages, modules, libraries, and then understanding how to package them and distribute as well as they deploy them, the one big reason is that it is very important for anyone to know how they could make their code available and accessible to millions of Python programmers worldwide. With converting your code as a Python library or module, you can make your code available to worldwide audience. You can make their application more enhanced, more applicable, and that is one big reason that you must know how to build the library, and everything goes around it to make it publicly available from start to finish. And that is what our objective is in this video series. So before we create our Python module, let's learn what will be the structure for our Python module, whether you are creating a very simple module or whether you are creating a very large. The structure has to be same. So first you are going to define your module name, and within the module name you are going to use the src or the source directory where everything related to the module name code is going to be there. And whenever you are going to create a module in Python, you also need to add the test for that module. Reason you need test because the module is a headless. It means you cannot run the code with the module. So by using the test method, you can actually validate that your code is working correctly or not. Besides these two, src and test folder, you need few files at the root of your module. These files are Setup.py. You also need the requirements.py. Requirements.py is going to explain the number of packages needed for this application, and the setup.py is going to include the setup configuration of your module, which will help us to create the wheel file or the Python package file to distribute it globally. Finally, the init.py or the dunder init.py. After our root is added, one optional file you can think about using the readme.md like a markdown file if that is your choice, but that is totally optional. After that, you are going to add the init.py or the dunder init.py in your source folder along with your module name. And make sure that the module names are the same, which is much easier to work with. unless you have multiple modules, and then things get a little more complex. But for the simplicity, you can keep the module name at the root and here both same. Next, you are going to create the init.py or dunder init.py inside the module name, followed by all the files you have and depending on whatever folder structure you would want. Similar to SRC, you also need the files inside your test folder. You can write as many as test files you would need to support your code testing, followed by the init.py or the dunder init.py. And these files are needed for every folder so that the package can be built correctly and it can be utilized correctly whenever it is applied in any Python code. So this is the skeleton for any Python module which you are going to create. So if we are going to create our ramp utils module, that is going to design something this, which is similar to the structure we have. Here we have the ramp utils, our module name, which is followed by SRC and test folder. We have the test API followed by the dunder init.py in the test folder. In the SRC, we do have the ramp utils along with the init.py with multiple API as well as the API implementation.py files. So let's go ahead and build our structure as we have just discussed here. Now we are going to create our Python module as we have. So let's create our Python module similar to the structure we are seeing the left side of our screen. Let's create a new Python project. We will call it ramp utils and it is going to use the existing Python 3.10 Conda environment. So this is the default or the base Python project structure provided by the PyCharm IDE. We do not need any of this, so we can actually remove this. We do not need the main.py, so we can delete this as well. Now in the ramp utils, we need to create two folders. SRC, next folder is tests. Then we are going to create these three files. We have created these three files. Now let's create the init.py inside the SRC folder. Let's also create the init.py in the test folder. Then in the SRC, we can create the module, same ramp utils. Inside the ramp utils, let's create the dunder init.py. That's our structure. Then we can also create here the api.py. And in the test, we can also use the test api.py. So that's the structure we have built up for our application. And here is the whole code which we have created earlier for our application. So we are going to just take this whole code and use it just to get us started. Let's come to api.py and we have copied our whole code here. Choices, here is the calc method. So in this ramp utils, we have the api.py and here is the init.py. So if you could see here that the api.py where the implementation of our calc method is, so we can call it that this is actually the implementation. So this is the calc implementation, and in the init.py, we can actually create the calc method. We can say from API import calc implementation, and here we could define the calc method, which is going to have the choice as well as the argv. As you could see here, this is taking choice in argv, and we are passing exact same operator. There you go. So for outside world, the calc method is going to be seen, but inside all the implementation is done in the calc implementation. So that's the init has access to our calc implementation. Now the biggest question comes, how we can test it? And that's very true because our ramp utils does not have any head, means the entry point. So the entry point does not belong to any module. So the best way to test is to use the test methods. So let's come back to test.py. Here we can run the test. So first we need to make sure, can we access the ramp utils here? So let's see. So we can say from src, we have access to there. We have access to ramp utils. Import. Can we access calc? Okay, so we have access to calc method, which is defined here. That's very good. Next, we can check if we could perform the test. Then we can actually make a call. So we could say calc and addition 4, 5. And if we are trying to perform the test, we can actually do the proper testing using the test modules which are available in Python. So before we go, let's make sure that it does work. Let's do the print. Now coming back to the project configuration, we just call it that this is running on Python 3.10. So that's just a name. Here in the ramp utils, we need to make sure that we are actually using the tests and test API, tests, test API .py, and the root is ramp utils. Run the code. And now you see here that the code is actually arriving to the ramp utils, but it cannot figure it out, no module in API. So the way you can solve this problem is that you can come to here and you can say that this is we are using. So we can say that src.ramputils.api. So it has a full path here. Now we come back to our test API, run the code again, and at least we do not see the error. Now we can go and we can actually set up a breakpoint here. Let's debug this code. Now we are here. It means at least we have ability to get inside our calc method. Let's get into the debugger. Now we are in our implementation of the module. Let's go one more step inside. Now we can look into addition. Everything is right. This is output. There you go. So the problem is here is that we are not returning this result. We need to make sure we are returning this result. Run it. This time we run, we are going to get the result back. So this is the print method which is generating the result, but we need the assertions. So in order to fix this problem, you can actually use the assert. And assert, you could say that this method should be equal to 11. And this is our assertion. Let's run it. You will see that there is assertion error. It means this line is not right, but there is another problem. When this result is coming out, let's actually make sure that we understand this part correctly. So when this line is being printed, if you see the result 11 is the first value based on 0 index, so 0, 1, 2. It means if we would want to get 11, we need to make sure that we are printing the first value from our list item. So we need to make sure that in the assertion, we are also making sure that the first value is 11. Now we can comment this line and bring the assert back. Now you see there is no error. But if you put a 12 here, the assertion failed. So that's how you will be able to track the assertion error. If we build the assertion for subtraction, let's have all 4, multiplication and the division. You see, so division, we could actually say 2 divided by 5. The result should be 0.4. If we are doing multiplication, this should be 30. And the subtraction, we could have 30 minus 5, which equals to 25. So these are the 4 assertions. Let me remove this line. This is wrong. Make 11. And there is no error. It means all assertions are correct. As soon as you make an error, that particular assertion is going to generate the error. So you can get an idea that how to write the test code, because this test code is validating whatever you have written here. If you are not going to use the test API, the problem is that your module code does not have ability to test. It's designed in a way that its library itself and the tests API is what is going to test it correctly. And you can also think about this test API is basically the application which is using the Reacp utils. The only caveat is that Reacp utils is not a general public library. It is just the module which belongs to Reacp utils project. So after the testing is done, it means now we have ability to take our code and we should be able to build a packaging around it so that it can be created as a Python wheel file. So in the setup, we need from setup tools, import, find packages and setup, because these are the two requirements we have. So we need to make sure that in the requirements we are requesting for setup tools and our output will be the wheel file. So we need to make sure that we are also including the wheel package. We are also asking for twine, which is needed, and finally the PyTest. So these are the packages which we want in our requirements.txt. Let's come back to setup. So these requirements means in order to use this package, we need to make sure that these packages are available. Let's create the setup content. So here you see that there is a setup. And if you see that the values which you could pass with the setup, here are the values you have. Lots of values, but we do not really need everything. So we are just going to use the basic minimum which we need in order to make this package. So we need name. So name is Reacp utils. Version we are going to use 0.0.1. Description Prodramp test util. Author Prodramp team. Email. License we can say it's MIT. Python requirements we could actually say anything above 3.7 and less than 4. So these are the basic requirement for our package. In the second section, we can look into what is really required. So we can say install requires. So if your installation require any additional libraries, you can actually write here setup requires all the setup related libraries you need it. Test requires, so like for example, PyTest, if you would want to use it, so you could say you need the PyTest, which is equal to 4.4.1. And this library also has the test suites. So we already know that this our test suites is available in this test folder. So we could say test suites, the test suite is, and that's our, let's put a comma here. That's the one error. I think all errors are gone. We do not see any warning related with our errors. So that's our setup.py. So we have made sure that requirement is also added, PyTest, and our setup.py. Sometimes you will see that the find package is also used here. Install requirements, find package, and you can actually say that what kind of package you are looking for as soon as. So this is also one requirement, but I will show you that for a basic application, you really do not need that method. After your module is created and the test has been completed, it is now time for us to work on our setup.py so we could package our module correctly. So first we need to work on our setup.py, which will help us to create the packaging structure for our module. Second, we need to update the requirements. It means the package needed for our application or the module to run correctly. Once it is done, we are going to run this command by using the python setup.py, which will generate a wheel file, which is the universal means used by both Python 2.7 and Python 3.x. If we do not want the universal, then we can create another wheel file, which is only limited to the current version. In both cases, we are going to have the wheel file. So here is an example of the setup.py, which has various configuration related to the packaging required for our module. Similar to setup.py, here is just a list of packages or the Python packages which are needed defined into the requirements.txt. And these packages are required for our module to work. Here is the command for us to run. Python is the command. Setup.py, we need to make sure that setup.py is at the root of ramp utils, which we have validated. It is there. And the bdist wheel, that our distribution method is to generate a wheel file, and the option is universal. Let's run this command. As you could see here, that our command ran successfully, and some of these new folders are created. Here is the build folder. Everything related to our project has been added here. Here you could see that we have created a universal file which is going to work with Python 2 and Python 3. And looking into the log, you could see that these files are being added into our project. We are not adding the test files, so only the code files are being added here. Next, if you want to create just the current Python runtime specific wheel file, then you do not need the universal option like this one. The command ran, and if we look into our distribution folder, we could actually see that there is a Python 3 specific wheel file is created. So now this is only for Python 3 and this is for Python 2 and 3, and rest is pretty much is the same. It means now we have ability to install this package in our other application here, and we can use this code. So now our next step is to install the Python wheel file which we have generated in this project. So just to make sure, the location for our distribution file is here. So we need to make sure that we reference this path to install our package. So let's come back here in the terminal. We make sure that the access to package is available here. Here we could say pip install the path and the file name. Let's use the ramp utils. This is our file name for Python 3. Install it. As you can see that installation has been completed. We can take a look that as you can see that this ramp utils, there was an error. Now we do not see an error. We can also validate by using the Python command, and we can say import ramp utils. Let's fix this error. So now everything is correct. And as you could see here that whenever we try to import the ramp utils, we did get an error because the src is not really being referenced correctly. So we can go back and look into our code, make sure our test is working. So our tests are working. We can come back to ramp utils. Here we are using src. We can actually use the ramp utils dot. So we should not use the src here. Let's run the test. Let's come back to test, check one more time. 12. Our tests are working. 11. Code is working. In the init.py, we do not need the src. Everything is good. Based on that check, now we can rebuild our package. We have built package again. And if you would want to just make sure everything is right, you can delete this folder and rebuild it again. Distribution, here is our file being created again. Let's come back. Quit. Install. And this time, if you will try to install, you will get an error because the ramp util is already installed. So in order to make it work, we can actually use this option, force install. Force install. So this force install will uninstall if the previous version is available, then reinstall it. Now we have reinstalled. Let's run the Python command. Import ramp utils. Now we do not see the error. It means this code is good. Ramp utils as REO. And if we run this code, which is available in app.py, we need to make sure we are referencing app.py. This is app.py. Everything is okay. Run it. And And as you could see here, all the print methods are correct. The submit must be numeric. We need to make sure division is correct, subtraction is correct, everything. Okay, let's remove this line, run it. Division, subtraction, and addition, all these values are correct. So this is how you have completed the generation of your Python module, which we have created here. So this way you have completed the generation of your Python module, which we conceptualize here and then implemented it completely in this Ramp Utils project. Make sure everything works in the test API here. And finally, we have installed as a package and used as a module and tested it that it works fine. So now we have completed the second part of our video, and at this point I believe that you have ample of information related to Python library development. All the code related to this project is also available at the GitHub repo. So the code which we have covered in this tutorial is available in DeepWorks GitHub repo. Visiting to developer program, you will find the Ramp Utils module folder has the code related with the Ramp Utils app, where we have created the code first here, and then the Ramp Utils library full code is available, what we have generated in the source folder and what we have added into the test folder. This module also has access to the Setup.py along with the requirements.txt. If you are interested just to have a sample package, how the structure for a sample Python module is going to look like, that's all here. The third and the last part of this video series is going to have the advanced information related to Python library development, where we will convert our existing Python library from current non-class based architecture to the full class-based architecture. And we are also going to learn that how to use the Python library various ways, like how you could deploy the bundles PyPy, or you can also install the Python library directly to your local environment without using any wheel package. So there will be a lot to learn in the very last part of this video series. So thank you so much for your time, and I'm looking forward to seeing you in the last part of this video series. Until then, thank you so much.